In this video, you will learn about popular technique of feature selection known as forward feature selection. In forward feature selection, we start training our model with no feature. It is an iterative method. In each iteration, we keep adding the feature which best improves our model until we reach a stage where addition of new variable makes no improvement in the performance of the model. Before I start coding, I'll tell you how it works. In forward feature selection, let's say we have all these independent variables. We have wine, malic acid, ash, magnesium, flavonoids. One, two. In forward feature selection, let's say we have a data set where we have 5 independent variables. The first one is wine, second is malic acid, third ash, fourth magnesium, and fifth flavonoids. And this is a target variable. So in feature selection, first it will consider the first feature and the target variable. So we will have in our first model, we will just have this wine variable and the target variable. Now in the second model, we will have two independent variables, wine and then malic acid and our target variable. In our third model, we will have three independent variables, wine, malic acid, ash and our target variable. In our next iteration, we will have 4 independent variables and a target variable. This process will go on. So let's say here in the fifth iteration, we have all the 5 independent variables and the target variables. So this process will go on until we reach a stage where we see there is no improvement in the accuracy of the model even after adding new features to our model. Let us see this practically in Jupyter Notebook. I'll import pandas as PD from mlextend dot feature selection. From this we need to import one class which is sequential feature selector. Now I'm going to read a CSV file and save in a variable df. From pandas I will call the method read underscore CSV, and inside this I will pass my CSV file name which is wine.csv. and if I check the head of this data frame, we will see here we have this data frame here. So we have many independent variables and we also have the target variable which is 0 and 1. Now we can also look at how many independent variables we have. So I will write here df.shape. We have total 14 columns. So out of this 13 are independent variable and 1 is a target variable. Now we are going to apply this forward selection, the forward feature selection technique on this data frame wine, and we will see out of these 13 independent variable how many of them are actually significant for our target variable, this target variable. Because if you keep adding all these 13 variables, this model will not make a good prediction. You need to find out which features are important for your model with respect to your target variable, and that we can find using this method feature selection. This is forward feature selection. Now let's do that. So for that, first I will check if there are any null values in our data set. I will write df dot is null dot sum. So it says that there are no missing values in any of the column, and we can also check if there are any missing values in a row. For that we will write df dot is null dot any and this time I will pass axis is equal to 1, and this is for row. So here you will see we don't have any missing values in any row. Axis is equal to 1 is for column, not for rows, but here we are checking if there are any missing values in any row. So we don't see any missing values in any row. Now we are going to split this data frame into x and y. So I will write here x, and from this I will call df.illoc, and inside this I want to take all the rows, so I will put here colon, and I want columns from 0 to 13. So I want to select the column numbers starting with this alcohol up to the 13th number column, which is pro line, which are all independent variables. We will skip this target variable. We will put this in y variable. So in x we will have all the rows and columns from 0 to 13, and in y we will have just the target variable. I will write df.illoc. I want all the rows, and to get the target variable, that is the last column, we will just have to type -1. And if I execute the code, so here it is saying syntax, okay, here I have to put colon here, not semicolon. Now if I type here x.head, so you will see that in x we have all the independent variables. We won't be having this target variable. Here you will see we have columns up to pro line, and in y we will just have our target variable. So you can see here we just have our target variable here. Next we will split our data frame into x train and y train. So I will call here from scikit-learn dot model selection import train test split. We will use this function to split our data frame into x train, x test, y train, y test. Now I will make those variable x train, then x test, y train, y test, and then I will call this function train test split, and inside this I will pass x and y, and then I will pass one more parameter, which is test underscore size. So our test size is going to be 0.3 or 30%, and random state you can put any number here. If you want your result to be same as mine, then you have to put the same number. Let's say I'll put here 100. Now we have this data set x train, x test, y train, y test, and now we are going to apply this forward feature selection technique, and we will see out of all these 13 columns how many of them are actually significant for our model. So I'll make one variable, and that variable name will be forward underscore feature underscore selection, and I will call this class sequential feature selection feature selector. And before this I also have to import the algorithm that I want to apply. So since this is a classification problem, I'm going to apply one classification algorithm, let's say random forest classifier. So I will import the class from scikit-learn.ensemble import random forest classifier. So I'll import this class, and it's taking a little time to import this class random forest classifier from scikit-learn.ensemble. Yeah, that's correct. Okay, now it's showing random forest classifier. Okay, so now inside this sequential feature selector we have to call the algorithm that we want to apply on this data set. And since I'm going to apply this algorithm random forest classifier, so I will call this algorithm random forest classifier inside this. So I will write here random forest classifier. First I need to run this code. Okay, now if I press tab, so I got this, and inside this I will pass one parameter which is number of jobs and jobs that, and I will put this one. So and jobs means how many cores you want to use. I want to use all the cores available in my laptop, and then I will put a comma, and now I have to pass the other parameters. So the first parameter is k underscore features, and this parameter is out of this 13 independent variables, so if I type the shape of this xtrain dot shape, so you see that we have 13 independent variables. So here you have to type manually out of 13 independent variables how many variables you want to be significant. So I will say, let's say I want 6 variables to be significant, and in the next step I will tell you, instead of giving it manually that we want 6, we will give here a tuple from 1 to 13, and we will ask this forward feature selection method to give us the best features automatically. So here we are writing it manually that we want 6 features which are significant. So this is the first parameter. The second parameter is forward, and this is equal to true because we want to do the forward feature selection. The third parameter is floating, and this you have to keep it as false. We are not going to use this floating. The next parameter is verbose, and we will type here too. So to check how the model is fitting, so we will get the results while it is fitting. And then the last parameter would be scoring, and scoring is equal to accuracy. We want to check the accuracy matrix. So based on this accuracy matrix, we want to select the best 6 features. And then we will also apply one more parameter, which is CV, and CV stands for cross validation. We want to do 5 times cross validation. And once you have defined all this parameter, now you have to fit this on our xtrain and ytrain. So I will write here xtrain and then ytrain. Now I will run this. As I've said that it will start model building or model fitting with no feature, then it will keep on adding 1, 2, 3, 4 until it reaches a stage where it finds that there is no improvement in the accuracy of the model even after adding the features. So now let's run this. So I have started running, and now you will see. So we are seeing this because of this parameter verbose is equal to 2. If you don't use this parameter, then you won't see this. You won't be able to come to know what is happening. Now it has stopped fitting the model. It has completed. So now if you look here, so in the first iteration you will see that out of 6 features, it used only 1 feature in the model and the accuracy was 77%. In the next model fitting, it used 2 features. The accuracy improved from 77% to 93%. In the third iteration, it used 3 independent variables or 3 features, and the model accuracy improved to 96%. In the fourth iteration, it used 4 features and the model accuracy increased to 98%. In the fifth iteration, it used 5 features, and here you will see there is a drop in the model accuracy. So from 98%, it went down to 97%, and in the sixth iteration also the model accuracy is 97.6%. So you can see here that there are only 4 features which are important in this model, and after adding those 4 features, if you want to add any new feature which is 5th, 6th, your model accuracy will not improve but it will go down. So there are only 4 important features in this model, and now we will come to know which are those important features. So now let's try to find out that. So to find out that, we will call this forward feature selection. So I will call this forward feature selection, and from this there is a method kFeatureIDX. Now if I run the code, so here you will see we are getting the index number of the column. So it says that the index number of these columns, so the column at this index number 2, 6, 7, 8, 9 and 12, these are the significant predictors in our model. But now if you want to see the actual names of these 6 columns, then we have another method. So I will call forward feature selection dot feature underscore dot k underscore feature names. So now here in the output you see these are the actual names of the features. So we have these features such as ash, flavonoids, non-flavonoid, then proanthocyanins. I don't know how to pronounce this word. Then the next feature is color intensity, and the last one is the proline. So out of all the 13 independent variables, these 6 features are significant predictors, and let's see how much accuracy we are getting on our model. And to check the accuracy, we will call our forward select feature selection object, and from this we will call k underscore score. So it says that our model has accuracy of 97%, because you will see here after adding this features, the fourth, after adding the fifth feature, the accuracy went down from 98% to 97%. And here also you will see after adding the sixth feature, the model accuracy was 97.976. That is why the final accuracy we got is 0.976. And we can also see how this is behaving using a pandas data frame. So here it is difficult to interpret how this is working. So to interpret this more easily, I will create a pandas data frame. So I will write here pd.data frame, and inside this first I will call from dictionary method, and inside this I will call this class forward selection, and then from this I will call the method get metric dictionary, and then I will transport this. Now if I execute the code, so here you will see, so first we have this feature which is at the index number 6, or the index number of that feature is 6, and here the accuracy was 77% and the feature name was flavonoids. So with just one feature flavonoid, our accuracy is 77%. Now in the second iteration with two features, the flavonoids and proline, our accuracy improved to 93%. In the third iteration, we have three features, flavonoids, color intensity, and proline, and the accuracy went from 93 to 96%. In the fourth iteration, we have now four features, flavonoids, and this new feature one, and our accuracy gone from 96% to 98%. And in the fifth and sixth iteration, you will see after adding new features, our accuracy actually came down. So this is how the model was working after adding the features. So we have this average score, the cross validation, the feature index number, the actual feature names, the confidence interval, standard deviation, and the standard error. So here I have shown you, we have given a default value or the fixed value that we want 6 features, but now instead of giving this fixed 6 features, I will ask the forward feature selection to select the best feature for us, not based on this 6 number, whatever it finds best, you give that result. So I will copy this code from here, and now I'll paste it here, and now here I will make a tuple, and inside this I will pass all the random variable which is from 1 to 13. And now I will run this code again, and it will start fitting. So once we stop, once it stops fitting the model, it completes. Then what we need to do is we just need to do all these steps one by one. That means we can call this step, then we can call this function. So I'll just copy this function, because this time we are not going to print the index number. Instead of that, we will just print the column names. So it has finished. Now I will run this again. From this feature selection, I will run this method k feature names. So now this time we are seeing that we got these 6 numbers of features, and if I copy this score from here and paste it here, so now this time we are getting 99% accuracy. That's great. And now let us see what are the features giving us this best accuracy. So I will do, I will just copy this code from here and paste it here, and let's see. So now you will see that, okay, so in the first iteration it used only one variable, which was flavonoid. In second iteration it used two variables, flavonoids and color intensity. So in the first iteration we got 78% accuracy, in the second 93%. In the fourth iteration with 3 variables we got 96% accuracy. In the fourth iteration with 4 variables we got 98% accuracy. In the fifth iteration with 5 variables we got 98% accuracy. And in the sixth iteration you will see that with 6 features we got the accuracy of 99%. So here the accuracy actually improved at this sixth position. So after adding 6 features, we got this accuracy, and those 6 features are here. So those 6 features, these are those 6 features: alcohol, alkalinity of ash, magnesium, flavonoids, color intensity, and proline. So if you use these 6 features in this model, you will get an accuracy of 0.99, which is 99%. And after adding those 6 features, if you add the 7th, 8th, 9th, 10, or any feature, your accuracy will not improve. And then we have these features: feature names, confidence interval bound, the standard deviation, standard error, cross validation scores, and feature index. So this is how you can use this forward feature selection technique, and you have to apply it on your data set, and you have to find how many features are significant and what are those features. Once you find those features, so instead of using the all the 13 features, you will use those 6 features which we got here. And if you use these 6 features in your model, you will get an accuracy of 99%. So this tutorial was about how you can use the forward feature selection technique to select the features, and in our next tutorial we will see the backward elimination technique, how we can use that technique to select the significant features for our model. I hope you enjoyed this video. If you like my video, you can subscribe to my channel. Thank you for watching.